Hello learners, hope you are doing well. So I'd like to welcome you all to the week 1 grade assignment solution video where we'll discuss the solution to the questions in the grade assignment for computational thinking. So before we start, I'd like to wish all the best to all our first time learners who have enrolled in this course and to all the learners who fell a bit short of making it to the course. Well, I would like to say that we'll keep on trying. I think you can crack the exam quite easily, and in terms of computational thinking, we try our best to do it together. So without further ado, I think we should jump into the first question. So here you can see that this particular step or these particular steps are actually valid for questions 1 through 3. So let's see what the question reads. So it says that what will the values of A, B and C be after the execution of the following procedure using the shopping bills dataset. So let's see, the step 1 says that we have to arrange all the cards in a single pile called pile 1. The step 2 says that we have initialized the variables A, B and C to 0. Step 3 says that if pile 1 is empty, then stop the iteration. So till here I think it's quite easy to understand, and step 4 says that you read the first card on the top card, in fact, on pile 1. So this is all going to be a repetition of steps. If you see further down, you're going to see the same 4 steps repeating in almost every procedure that we go through. The next step is where we have to actually put a focus on. So step 5 says that if the bill amount is greater, so that is the total bill amount, is greater than or equal to 500, then increment A. So what does it mean? So it means that if you find any bill amount, so you go through the data set, okay, you have a link that says click here for the data set. You go to the data set, you go to the shopping bills data set, and then you will see a list of shopping bills. So there you can just have a look at what these bills look like, and on the bottom of the card you will see the amount total written with the total amount that is given for each bill. And you can see that if any of these bills are greater than 500 or even equal to 500, you should increment the value of A. Increment basically means that you should add +1 to the existing value of A. So if you see, say, one card and then you go and read the next card and that also has, let's say, an amount greater than or equal to 500, then you increase the existing value of A by 1. Similarly, step 6 says that if the total bill amount is lesser than or equal to 500 and the total bill amount is greater than or equal to 100, then increment B. So it basically means that if you see anything less than 500, that is up to 499, and anything that is greater than 100, greater than or equal to, in fact, 100. So which means that from 100 to 499, if you see any bill amount, total bill amount in that range, well, you have to increment B. Similarly, step 7 says that if you see any bill amount that is lesser than 100, that means, let's say, 0 to 99, that is the valid range for which a bill can be, or not even 0, let's say from 1 to 9, because you can purchase something for, let's say, a minimum of 1 rupee. So from 1 to 99, if you see any of these bills, you have to increment C. And then step 8 finally says that move the current card to another card called pile 2 and repeat from step 3. So this is basically just going to through the cards again and again. Well, let's just move on to the answers. So just for the sake of simplicity, I have collected all the cards, okay, all the cards from the data set which actually had a bill amount greater than or equal to 500, and you can see that from here that there were actually a total of 16 cards. So that is what is going to be your answer. So what you're going to do is you're going to click on the line, the green line there. You're going to have an option to input a number. So you're going to input the number 16 because that is how many cards that there are whose let's say whose bill amount is actually greater than or equal to 500 rupees. Similarly, for question number 2, they have asked what the value of B is. So you can just go ahead and then count the number of cards here. You can see that here there are a total of 12 cards whose bill amount was between 100 and 499 rupees. So that answer would automatically be 12, because those many cards, or those many people in fact, bought items from each of these stores worth between 100 and 499. And finally, we had that last C, which says that we had to count how many people had bill amounts less than 99. That is from less than 100, in fact, pardon me, it was less than 100. So it was between 1 rupee and 99 rupees, which means that there were only 2 people. And so the answer for that question would be 2. So the first 3 questions were completely solved with the first set of steps. Now moving on to the fourth question. So question number 4 reads, the following pseudocode is executed using the words dataset. What will count represent at the end of execution? So let's read the steps. Step 1 says that we have to arrange all the cards in a pile called pile 1. Okay. We initialize a variable count to 0. Then if pile 1 is empty, we stop the iteration and read the first card or the top card on pile 1. So again, as I told you from the previous question, that these 4 steps are going to be standard in almost all of the procedures that you're going to come forward with. And let's see what step 5 says. It says that if the word ends with a full stop and the word is Monday, then increment count. So here there's something interesting. So the key word that we have to look for is and. So it says that only if there is a card that reads Monday and it has a full stop. So what does it mean? So it means that this Monday should be the last word of the sentence, or it should be the end of the sentence, to be precise. And it says that only if you find a card like this, you have to increment count. So let's say if we had a card which had the word Monday, but it had no full stop. So what does it mean? That it's just a Monday in the middle of the sentence. So we don't count that word, or we don't increment count if we see a Monday in the middle of a sentence. So if we have a sentence and we have a Monday here with a full stop behind it, so that means that we are including this entire sentence in that count, if that at all makes sense, because we are just incrementing the value of count each time we see a sentence which ends with a Monday. So that's basically all that we're counting. We're counting the number of sentences that have Monday at the end of the sentence. So, and then again step 6 says that we move the current card to another card called pile 2, and then repeat from step 3, which is obviously the standard procedure that's going to be done everywhere. Because let's say if we were to start from step 2, what's going to happen? We're just going to initialize count to 0 every time. So that wouldn't help, right? So that's why we are always going to step 3 and then reading the next card, and then we see that if the pile is empty. If it is not empty, we keep going. If it is empty, well, we just come out. So that's it. We are done with the iterations. So anyways, let's just read the options now. So the first option says that it is to count the frequency, or the frequency count of the word Monday in the data set. So no, as I told you that we're not counting all the Mondays, we're just counting the Monday that has a full stop. So if we find a Monday in the middle of the sentence, we wouldn't count it. It wouldn't be included in the count. Then the next one says that the number of sentences which start with the word Monday. That is absurd, because you don't see a sentence that starts with a full stop, do you? So it's definitely not that we are counting the number of sentences that start with the word Monday. Anyway, moving on to the third option, it says that the number of Sundays, the number of sentences consisting the word Monday at least once. Again, that's not correct. We know that even if we found a sentence with Monday in the middle of the sentence, we wouldn't count it. And finally, the last option says number of sentences which ends with the word Monday. So that is actually your correct answer, because we are only looking at a Monday that has a full stop. So the word that ends with a full stop, and it is the word Monday. So that can only mean that we're counting the number of sentences with Monday as the end of the sentence. So the correct answer for your question number 4 is actually your option D, or the last option. So there are no letters here, so let's just say that it's the last option, which says number of sentences which ends with the word Monday. So that is the answer to question number 4. Let's move on to question number 5. So question number 5 reads, a student proposed a hypothesis that more people are born in the first half of the year than the second half of the year. She wrote the following procedure, which uses the scores dataset to verify the hypothesis. So again, the first 4 steps, I think you should be aware of all these steps by now. It says that arrange all the cards in a single pile called pile 1. Then you maintain the variables a and b and initialize them to 0. If pile 1 is empty, then stop the iteration and start from step 8. Then you read the top card in pile 1. So these 4 steps are standard. So now what we have to do is, we have to use logic, right? We have to try to understand what's at play here. So let's just have a glance at the first and second option, because in these exams, as important as it is to know what you're doing and know the steps and all those kind of things, you also need to learn to eliminate options just by mere logic. So let's see steps 1 and 2. So in steps 1 and 2, as you see that, pardon me, in option 1 and 2, but let's move to step 2 here. In step 2, as you can see here, what we have done is we've initialized a and b to 0, right? And then we have a few steps, and step 7 says that you move the current card to another pile called pile 2 and repeat from step 3. So we are in this loop, okay? We are in this loop until pile 1 is empty, right? And when pile 1 is empty, what do? We go to step 8. So we are in this particular loop till the pile is empty. But what happens if we were to choose either of option 1 or option 2, right? If we were to choose either of these options, what would happen is, we would just keep on comparing a and b as long as they're 0, because there is no incrementing done because here it says that step 5 is, that is this step, should be that we compare a and b and then declare them to be either false, and if they're the same, then declare them to be true. Similarly, here also we are to compare them and then declare them to be false. Same thing here. So think of it logically. Nowhere in the first 2 options in steps 5 and 6 are we incrementing anything. So a and b just remain 0 until you see all cards, okay? And then finally you try to increment a, but by the time you have no cards more to look at, right? So automatically you should be able to understand that, okay, this is logically incorrect, okay? There is a logical error in this, in fact. So just eliminate options 1 and 2 or any of these options as soon as you see them, so that those are 2 less options that you have to worry about, and you increase your chances by, let's say, 50%. Okay, so we have done with this. We have eliminated options 1 and 2 because definitely they do not look logical. Okay, so from this what we understood is steps 5 and 6 are something where you have to update the value of a and b, let's say. So in this case, updating just means that we have to increment a and b because this person wants to prove their hypothesis, right? So let's just go to option 3 and see what does that say. It says that the date of birth, that is, if the date of birth was from 1st January to 30th June, then increment a. So that means in this option 5, a represents the first half, right? Actually, in both these cases, even in option 4, option 3 and option 4, a represents the first half and b represents the second half. Okay, what else? Now we have incremented it from step 5 and step 6, and then you move through from step 3 through step 7 until you are out of cards. Okay, once you're out of cards, then they will ask you to come to step 8, and here is when you should actually start comparing, because once you actually have the cards, you can now start comparing your values, right? So let's see what step 8 says. Step 8 says that if A is greater than B, okay, the hypothesis was that more people are born in the first half of the year. Just I'll underline that part for you, that more people are born in the first half of the year than the second half of the year. So this is the hypothesis that they want to be proven to be true. So what does option 3 step 8 say? That if A is greater than B, that is, if the number of people born in the first half are greater than the number of people born in the second half, then the hypothesis is true. This is exactly what we wanted. It also says that if A is lesser than or equal to B, then declare the hypothesis to be false. That is exactly what our criteria is. That's exactly what we want. We want more people. It does not say if it is more than or equal to, it says just more people, so it means greater than, right? So if it had said that, if let's say the hypothesis said that more than or equal to, well, in that case we could have taken A greater than or equal to B, but since it doesn't say equal to, just says more than, so we have to go with the greater than sign, right? So as you can see from here, option 3 is the correct answer. But just to give you guys a better picture, let's see why option 4 is not the answer. So option 4 says that if A is less than or equal to B, then declare hypothesis to be true, which is not true, because we know that we are searching for a hypothesis in which more people are born in the first half of the year than the second half, which means that we want A to be greater than or equal to, A to be greater than B. Only then can we declare the hypothesis to be true. So in that case, we have already failed in option 4. So that is why the correct answer to question number 5 is option 3, that is this particular option. So with that, let's move over to question number 6. So question number 6 reads, what will the given procedure compute and store in variable x if executed on the shopping bills dataset? Okay, so let's go through it step by step. Step 1 says, arrange all the cards in a single pile called pile 1. Step 2 says, maintain 4 variables a, b, c, x and initialize them to 0. Step 4 says that if pile 1 is empty, then stop the iteration and start from from step 9. Then you read the top card in pile 1. So again, 4 steps that we should all know. It's quite common by now. Step 5 says, and here's where the actual computation things start from. It says that if the shop name is SV Stores and customer name is Nirja, then set A to 1. So here we're not incrementing anything. All we're doing is, at the first instant, okay, at the first you will have a lot of cards, right? You will look through these pile of cards that are arranged in a pile, in fact, and you will just be going through these cards one by one. You will first look at this first card, then second card, then the third card. At the first instant, let's say according to step 5, in the first instant that you see a shop name that is SV Stores and the customer's name is Nirja, all that you have to do is A is equal to 1. That's all. Okay, now even if you see the card for a second time, let's say on this particular iteration, okay, on this card you again see SV Stores and Nirja, well, this will not change. Okay, A will still remain 1. So it just means that Nirja has visited SV Stores at some point in her life. Okay, let's just keep it at that, or as how long ever the observation took. Okay, so she has visited SV Stores, that is Nirja has visited SV Stores at least once. So we have seen that, and now even if we see that Nirja has visited SV Stores again, we do not change the value of A, it remains equal to 1. Okay, so that is step 5. Step 6 says, again here this is almost the same thing, only difference is that the store name is different. So it says that if the store name or the shop name is Big Bazaar and the customer name is Nirja, then set B equal to 1. So remember, they were all first initialized to 0. Okay, initially A was equal to 0, B was equal to 0, C was equal to 0, and there was this variable X that is also equal to 0. So in the first instant that you see SV Stores and Nirja, this shop name is SV Stores and the customer name is Nirja, you will increment A to 1. The first instant that you see the shop name as Big Bazaar and the customer name is Nirja, you just keep the value, you remove the value 0 and you replace it with 1. Similarly, if you see in step 7, if you see the shop name as Sun General and the customer name is Nirja, again just replace the value of C from 0 to 1. And what you do is in step 8, you move this card to pile 2 and then again you repeat from step 3. So you see here step 8 to step 3 and step 3 to step 8 again. So this will keep on continuing until you are done with all the cards in pile 1. Okay, so you have moved entirely through these cards and this is the last card, and finally when there are no more cards to see, you make it to step 9, and then what you do is you just take a summation of all the values of A, B and C as you see them. Okay, so let's say in a particular set of iterations Nirja had visited SV Stores at least once, that is why it was incremented. She had visited Big Bazaar at least once, which is why you got a value of 1. Okay, but Nirja had never been to Sun General, let's say, so C remained 0. So what will happen is that at the end of iteration, you have gone through the entire data set. At the end of iteration, what will happen is the value of X would be 2. Okay, so it would never say that she has visited Big Bazaar or SV Stores or Sun General. It would just say that Nirja has visited 2 distinct stores. So that's all it would say. It would not say that which are the 2 distinct stores. It would just say that Nirja, throughout whatever time it took to take these observations, she has only visited 2 of the 3 stores that are there in her vicinity. Okay, so what that would mean is that the value X would represent the number of distinct stores which Nirja has visited, and which subsequently is your option number 4 in this question. So that is the correct answer to this question. That is that the correct answer to question number 6 is option number 4, which reads X represents the number of distinct stores which Nirja has visited. So with that, let's move to question number 7. So question number 7 is quite interesting. Let's read the question first. It reads, the following procedure is executed using the words dataset. At the end of execution, count stores the number of words with part of speech noun and letter count greater than or equal to 4. So this is something that you need to remember. So the part of speech is a noun and the letter count, remember this, is greater than or equal to 4, right? But the programmer may have made mistakes in 1 or more steps. Again, something to remember, 1 or more steps. Identify all such steps, if any. And what's interesting to note here, actually what I was aiming at, is that it's a multiple select question. So we have dealt with 2 distinct type of questions till now. From questions 1 to 3, we had something like a numerical answer type question where we had to type in the numbers. Then from 4 to 6, we had a multiple choice question which had, let's say, a distinct answer. It just had one answer. You see the first correct answer, you click it, you move on to the next question. But this is a multiple select question, which means that you can have 1 or more correct answers. So as soon as you see the first correct answer, don't move on to the next question. You have to take your time for these questions. You have to look at each of the options carefully, and if you think that 1 or more of these answers are suiting your criteria, well, you have to choose them, and then and only then do you move to the next question. So anyways, let's read the question once. In fact, let's move into this procedure. In fact, So step 1 says that arrange all cards in a single pile called pile 1. Okay, that's quite straightforward. Step 2 says maintain a variable count and initialize it to 1. Okay, so there is some sort of an error here, I think, because as you remember from the previous questions, you always initialize your count variables from 0, so that the first time you see your something that is fitting your condition, you initialize it and then that becomes your first count, right? So imagine if you had initialized it to 1 and you see your first noun with letter count greater than or equal to 4, the value of count would be 2, which would incorrectly show that you have seen 2 of these nouns with the letter count greater than or equal to 4, but actually you have only seen 1. So you see that's an error right there. So that is your first error. So let's just mark step 2. Okay. Now step 3. It says that if pile 1 is empty, then stop the iteration. Okay, that's also quite straightforward. It's logical. Step 4 reads, you read the top card on pile 1. Again, no issues there. Step 5 says, if part of speech is verb and letter count greater than or equal to 4, increment count. So you see already you have the error here. So you remember what we had underlined. We want the part of speech to be a noun, which clearly it is not. Okay, already we have already found the error here, but let's just see if there are any more errors in this step, just for a practice. Okay, so you see that the letter count is greater than or equal to 4. Okay, and here as you see that it is actually matching the criteria. Letter count is greater than or equal to 4 and then increment count. So you just had one error in this step, which was enough to make the entire step wrong. So step 5 is also wrong. Okay, so step 6 says move the current card to another pile called pile 2 and repeat from step 3. Again, right, that is also the correct thing to do. So till now we have seen 2 steps that have something that have sort of mistakes in them, and those 2 steps are step 2. Okay, so that is one step which is actually wrong, and then you had step 5. So you see step 5 was also incorrect because the part of speech was a verb. So as it is correctly said that step 2, it is an incorrect initialization of the variable count. That is correct. Step 5 says it is an incorrect condition to update count. So because we didn't want to increment when we see a verb, so that's when it did the count. But option 5 says no mistake, but you already found 2 mistakes, so that's definitely not an answer. So for your 7th question, you have 2 correct options, that is option number 1 and option number 3, which are in the step 2 and step 5 respectively. So with that, let's move on to the next question, which is question number 8. So question 8 reads, the given information represents a scores dataset and it may have some mistakes with respect to the sanity of the data, and you have to identify all rows with such mistakes. And again, you see it's a multiple select question, so don't just move on to the next question as soon as you see a right answer. Take your time. Okay, go through each of these rows, each of whatever data you get, go through each of them carefully. Okay, you have to ascertain that you have no more mistakes before you proceed to the next question. So anyways, let's go on with row 1. Row 1, the field says card number. Okay, but the value given is Harish. Does that make sense? Because the field expects a number, but we have inputted something of a string, right? So definitely that's not correct. So row 1 does have an error. Okay, fine. Okay, fine. Let's move on to row 2. We have found an error, but let's mark it for now. Okay, and let's move on to row 2. Row 2, the field is name, but you see here we have inputted an integer. How does that make any sense? So again, there is some issue here. Mark it. Okay, do not move on to the next question so quickly. Let's go to the next row, row 3. It's gender. Okay, and you knew from the scores dataset, you know that gender is just a single character, right? It could either be M or F. M for male, F for female. So we have given that field what it expects, either M or F, which means this particular row is correct. Okay, row 4 says date of birth. At the first glance, you might think, oh, it's fine. We see February, we see, oh, fine, that's great. It looks good. But then on a closer inspection, you see that it says 30th February. Does February have 30 days? Even on the leap years, it has 29 days. What's 30th February, right? It looks like a prank or something like that. So definitely that has some issue there. We mark it. Moving on to row 5. It says mathematics. Okay, great. Mathematics expects an integer. We give it an integer. But what is the issue here? 662 for mathematics. A paper which you score out of 100, right? From the scores data set, you know that each individual subject is out of 100. How the hell did somebody score 662? So, and that's quite ironic that it happened on a math subject, right? So row 5 is also an error, which means you have found 4 erroneous rows till now, okay? But we are still not done. We have to go now to row 6. Row 6 says physics and the person has scored 45. Granted, the marks may not be up to the mark, but it's still in the range of our data, okay? So this 45 does fall in the range of 0 to 100. So that means this row is correct. Row 7 is chemistry and they have scored exceptionally well and it's still in the range. So that is 91, which falls between the 0 to 100 bracket. Great. And now we go to the total. So we have maths, physics and chemistry, 3 subjects out of 100 marks. But what do we have here? We have a total that is more than what should be, mathematically possible, because we have 3 subjects of 100 marks each, which means the total should be out of 300. But the total seen here is 398. So it is neither equal to, the addition or the summation of all these 3 marks, nor does it fall in the range of 0 to 300, because all these marks should actually be out of 100. This should be the maximum possible marks for each of the subjects, which should come out to be 300, but this person has somehow scored 398 out of 300. I'm not sure if they got extra marks for good handwriting, but that's a little too much in my opinion. So that is also an erroneous row. So as you can see that there are a total of 5 rows which are erroneous, and we have to just mark them in the options. So there you have row number 1, which was erroneous. We have row number 2, and then row number 3, there was no problem. Row number 4 had an error, as you see, an invalid date of birth, and then row 5 also had an error, and then finally all the way down we had row 8 that was erroneous. So which means that there are 5 correct options for question number 8, and the errors were in row 1, row 2, row 4, row 5 and row 8. So with this we are done with question number 8. Let's move on to question number 9. So question number 9 reads, match the following by selecting the most appropriate data type specific to words dataset for the left column. So the words dataset, if you remember, the first field name is gender of the student, and you know that the gender of the student can either be M or it can be F, where M stands for male and F stands for female. So these are the 2 genders that is possible, or the 2 inputs that are possible for the gender of the student. And so as you can see that M and F, these are just single characters. So they are character data types, right? So there is only one option possible for the gender of the student, which is character. So again, I told you about being smart, right? You have to be smart. You have to initially eliminate all the options which you think will not suffice. So you see that there are only 2 options available, in which one goes to 4, that is option number 2 and option number 3. Option number 1 and option number 3. So in that case, now we have to just look at the next few options. So let's see. So the second field name is name of the student, which we all know is a string because it is a list. It is just going to be a bunch of characters together, and like we had, suppose, say Nirja from one of the previous data sets. So it's all just a bunch of characters that are put together and they form a string of characters. So name of the student is going to be a string. So that is correct in both of these options as well. 2 goes to 3. Then let's move on to the third one. The third one is the marks in a subject, and the marks can only be, in an integer fashion, ranging from, let's say, 0 to 100 for individual subjects, or 0 to 300 for the total. So in that case, 3 can only go to the first data type, that is your integer. That's also correct. Now where the difference lies, as you can see, is in option 4 or the field 4, where you have to check the city of a student. So here in option number 1, it says the city of a student should go to 4, which means that it should be a character, but you know that the city is more than just one character, right? Let's say there was a city like Erode. So it is a string of 5 characters. So let's say if there was a city called Erode in one of the cards, so you can see that there are multiple characters here. So it's not just one character that this string is representing. So automatically you go to option number 3, which says that the fourth field name, which is city of the student, should go to the third data type, which is actually string. So in this way we played smartly. They have not said that each of these field names will only have a single data type in each of these in the right hand side column, right? The data type can be useful for 2 field names as well. So there is no constraint like that, which means that the correct answer for your question number 9 is actually option number 3, and these are the correct options. So with that, let's move on to the last question for this computational thinking assignment for week 1, and let's move on. So question number 10 reads, let A, B and C be 3 distinct integers given as input to the following flowchart. So again, you see that we start our flowchart from here, right? And these arrows, they represent where is the flow of each of these procedures. So first we have 3 variables, A, B and C. Okay, we have not initialized them to anything. Then we have initialized a variable called x to 0. So let's say A, B and C are user given or user defined inputs. So we get to choose what A, B and C mean. But x as default is 0. So in the first decision terminal, what we do is that in the decision block, we say that if A is greater than B. So if that is true, let's say if A is greater than B, we choose this path. And now we check if C is greater than A. Okay. So as of this point, considering this to be true, A was the greater variable, right? A was the greater variable. Then we come to this decision block, which says that if C is greater than A, so A already being greater than B, and if C was also greater than A, this would be the case, which means that right now C is the largest variable among the 3, and that would be the value of x. Now let's say that A was greater than B, right? But then we come here and we see that C is not greater than A. So we go into this false terminal. So that would mean that C is actually not greater than A. It's between A and B, or it could let's say be greater than less than C or less than B also. It doesn't matter. But what would happen is that by default A would be the largest among the 3, right? And that would actually be the value of x. So just by these two options, you can see that x is taking the value of the greatest among the three. But let's see if this is actually true in all cases. So now let's go to the false side. Let's say if b was greater than a. Okay. Now it will check if c is also greater than b. In case c is greater than b, what would happen is x would take the value of c, which is again the greatest of all the three integers. And if it is not, that means if b is greater than c, okay, if b is greater than a and greater than c, which would make b the greatest of all three of these integers, which would mean that x is now taking the value of the greatest among the three integers. So in all the cases that we have seen in this flowchart, we have seen that x takes the value of the greatest among the three integers at the end of execution. So the question 2, what will x represent at the end of the flowchart? Well, it would take the largest among a, b and c. So that is the correct answer to the question 10. So the correct answer is option number 3, which reads x would take the largest among a, b and c. So with that, learners, I hope you were able to solve these questions. You were able to in fact understand why some of the solutions came out to what they were, and I hope this has helped you further your learning and further your understanding to these problems and how to solve these type of problems. You need not always try to put in 100% of hard work and read each question and solve them. Sometimes you just have to try to eliminate some of these problems, work around them smartly, so that you can save some time and you will be able to finish these papers earlier, so that you can go through and glance through the options once more, so that you know that you're not missed out on anything. So having understood a few of these tips and tricks, I hope this will help you in your further lessons also, and all the best to all the learners. Thank you, learners.